Hi, my name is Mel, and the following presentation will look at advanced computer motherboards, architect features, and innovations. So, and like, we'll cover everything from basic motherboard design to advanced technologies. All right. So today we'll begin by understanding motherboard fundamentals and architecture, and then analyze key components in detail. Next, we'll explore expansion options, power delivery, integrated features, overclocking capabilities, specialized applications, and finally look at future trends and innovations. Okay, the following section focuses on the basic concepts of motherboard design, including its core functions, common form factors, and the main components that constitute a motherboard. A motherboard is the primary circuit board that connects all components of a computer. It facilitates communications between the CPU, memory, storage, and peripheral devices, providing the electrical pathways and control logic necessary for system operation. Motherboards come in various sizes called form factors. ATX is a standard full-size board. Micro ATX and ITX are smaller compact builds, and eATX is larger for higher performance or server systems. Each influences compatibility and expansion options. So you're going to have to look at what you want. So if you're going to look gaming, you obviously want like a higher degree of a motherboard, like an eATX, or a server system's an eATX. Most computers would might take an ITX. Some would ATX. You know, it just depends on what you're going to want for. Okay. Key motherboard components include CPU socket, chipset, RAM slots, expansion slots, power connectors, and storage interfaces. Each play a crucial role in enabling hardware communication and functionality. Okay, in the following section, we'll examine critical motherboard elements in depth, including CPU sockets, chipsets, and memory interfaces to understand their specifications and compatibility considerations. CPU sockets determine what processors a motherboard supports. Different manufacturers and architectures use various socket types, so matching the CPU and socket is essential for system compatibility. So if you're buying a motherboard just on its own, you want to make sure that it's capable of taking a CPU that you want. Intel's usually one of the better ones, but there are others, AMD, others as well. And you know, like there's an Intel i9, but you can get like many different types of processors. Like PC part pickers, you can get like I would get an 8-core processor or 16-core processor. If you like gaming and stuff like that, or a server, you definitely want 16-core processor, maybe not 2 processors. But that's all what you need to look at, is what are you going to use it for, okay? Chipsets manage data flow between the CPU, memory, and peripherals. Leading manufacturers like Intel and AMD design chipsets that define motherboard features, performance, and supported technologies. Okay, so that's something to note as well. Motherboards provide slots for RAM modules supporting different memory types such as DDR4, DDR5, and configurations such as dual or quad channels, which affect system speed and multitasking capabilities. And I would, you know, the quad channels are good. And generally, the more memory you've got, the more RAM you've got, the better performance you're going to have with your system. If you have too little RAM, your system's just not going to be able to operate with a lot of different programs or operating systems that are available today. The same goes with your CPU. You've got to have a certain level of CPU, otherwise a lot of software just won't run. It's just as simple as that. All right. The following section covers various interfaces and slots that allow users to expand and connect devices such as PCI slots, storage connectors, and USB standards. PCIe slots enable installation of graphic cards and other expansion cards. So you can have like a integrated graphics card, or you can have an external graphic card. And I would also have a GPU, graphics processor unit, because that would help your graphics, especially if you're gaming or anything like that. So you want a GPU as well as a graphics card, in my opinion. M.2 slots support high-speed SSDs, which you do want high-speed SSDs for most systems. You can get SSDs of like about 2 terabytes nowadays, some bigger. You can also have a HDD and an external drive. So look, if you're backing up information, you want it like on you want it on external drive, cloud, and on a hard drive somewhere. SSD, like if you're running video games and stuff like that, you want it will enable the more SSD, you know, like you want games stored in there, faster retrieval, anything like large files being saved, image files being saved on an SSD quicker than an HDD. It just is. Okay. But like this is where you look at, like if you're saving stuff to an SSD at night or when you're not using the system, you should set up your computer to back up to like the HDD and to your external hard drive. And I would also save stuff to a cloud as well. All right, you should have multiple colors. So while legacy ports maintain compatibility with older peripherals. So look, you should have many different methods of backing up, and backing up is important. Okay, so storage connections include SATA, SATA, NVMe, and RAID support. So RAID configurations that combine drives for enhanced performance or redundancy, and redundancy is what you want. Okay. Okay, so SATA is commonly used for traditional hard drives and SSDs. NVMs utilize PC lanes to deliver ultra-fast data for solid-state drives, and RAID can use multiple drives, you know, stuff like that. Motherboards support various USB versions from USB 2 to USB 4, so that includes 3, offering differing data transfer speeds and power delivery capabilities for versatile connectivity. And there are different types of USB connections, USB A, C, B, C, that sort of stuff. And you need to look at, generally USB A is for older and generally can't do power. Like, so if you've got like something that needs power, then I would not use something like connecting to a USB A like sort of thing. But yeah, it's just going to depend on what you've got. All right. Reliable power delivery is vital for stable operation. The following section discusses power phases, voltage regulation modules, capacitors, and cooling solutions that ensure motherboard durability and performance. Because if things get too high, your motherboard's just not going to, it's going to stop working and probably cease to work ever again, quite honestly. So you need heat sinks and good, like sometimes water cooling, depends on it. Power phases and voltage regulator modules, or VRMs, control and stabilize the voltage supplied to the CPU and components impacting overclocking potential and system reliability. Because look, you should also plug in computers to a standard, like a stable power supply, like uninterruptible power supply, or like a specialized thing that can, like, smooth your power supply out. Because, like, computers and electronics in general are and electricity in general can be very dirty. When I mean dirty, its voltage can be a little bit all over the place, and its current can be all over the place. So you definitely want something like plugged into like a smart, power board, and also have like smart power for your building, so that hopefully voltage is controlled. And as I said, an uninterruptible power supply if it's a business or something, because otherwise you're just going to get a lot of trouble. Okay, capacitors help smooth voltage fluctuations, reducing electrical noise and enhancing component lifespan. High quality capacitors contribute to motherboard stability under heavy loads. Okay, and that's important. Effective cooling methods include heat sinks, fan headers prevent overheating for critical components like voltage regulation modules and chipsets, maintaining system stability and longevity. So if you don't have efficient cooling methods, which for some you won't, then you need to probably power down your device, like to extend it, basically. Modern motherboards include numerous integrated controllers and features such as audio, networking, sorry, I'm taking my jumper off, firmware, interfaces, and aesthetic enhancements to improve user experience. Motherboards often come in with inbuilt high-definition audio, Ethernet networking, wireless connectivity options like Bluetooth and Wi-Fi, reducing the need for additional expansion cards. The BIOS, or the UEFI, provides the low-level interfaces to configure motherboard settings, update firmware, and control boot sequences, with modern UEFI offering graphical interfaces and advanced tools, which is something you need to might be change this if you're having issues with your computer. Many motherboards now feature RGB lighting and customizable design elements, allowing users to personalize the appearance of their builds, especially popular in gaming and showpiece systems. The following section explores tools and safety features that enable users to push CPU and RAM performance beyond default specifications while protecting hardware integrity. Motherboards provide inbuilt overclocking utilities within BIOS UEFI to adjust frequencies, voltages, and timings for CPU and RAM, enabling performance choosing tailored to user needs. You want to make sure it's not really well above what is recommended, because you'll just kill it. If it has to be above what's recommended, then you need to get a better motherboard or better chip, like CPU and stuff like that. All right, it's just, this is something you should do with a great deal of care. Real-time monitoring of voltages, temperatures, and fan speeds helps users maintain safe operation during overclocking, with some motherboards offering software and hardware alerts. Safety mechanisms like overcurrent protection, thermal throttling, and reinforcement components protect the motherboard and connected hardware from damage due to stress or faults. Choosing the right motherboard depends on the intended use case, whether gaming, professional workstation, servers, or compact custom builds with unique requirements. So again, you need to decide what this is going to be for, and then you can look at, like pick parts and PCs and different builds and different capacities that you can have to build your system. Or you can just buy a pre-built system too. That's nothing wrong with that. And I buy pre-built systems most of the time because I can't be bothered. It's not worth putting something together yourself. It's not worth the hassle. It's usually cheaper to buy a pre-built system often too, quite honestly. So gaming motherboards prioritize high performance chipsets, advanced cooling, enhanced audio, and RGB lighting to deliver immersive and stable gaming experiences. So gaming computers need a lot more high end like CPUs, a lot more RAM, right? You need a lot more, higher SSD, higher hard drive. You want high graphics, GPU and a graphics card. You want often a better monitor and audio and all that sort of stuff. Gaming, you can get gaming mice, keyboards, and you want also maybe attach gaming controls like a joystick or something or anything like that. These motherboards support multiple CPUs, ECC, so workstation and server motherboards is what we're talking about here. ECC memory and extensive connectivity, optimized for reliability, multitasking, and heavy computational workloads. So workstation and server motherboards, will need to have multiple CPUs. You will. There's just no getting around that. There's absolutely no getting around. ECC memory, definitely, for sure. Extensive connectivity, yeah, you'll need. So you'll need to get if you want to build your own server, you probably need to get specialized server motherboards and have multiple CPUs, and you want more better ones. So you would have to look at, and you can buy specific server motherboards, or you can buy server hardware. All right, that's like just a server pre-built. Smaller form factors such as mini ITX enable complex setups that are ideal for space-contained environments or aesthetic custom builds, balancing features and the size constraints. Looking ahead, motherboard technology is evolving with fast interfaces, AI integration, and eco-friendly materials to meet rising performance and sustainability demands. Yep. New PCIe generations increase data transfer speeds, enabling faster graphics, storage, and expansion by significantly impacting overall performance. Emerging motherboards incorporate AI for intelligent system monitoring, automatic tuning, and fault detection, enabling ease of use and system reliability. Yep. So manufacturers are adopting greener materials and energy-efficient designs to reduce environmental impact while maintaining high-performance standards. And look, this is something that should happen all through computing and all through, servers, routers, whether it's your desktop or laptop, having stuff that's way more energy efficient and greener, using greener materials is something that's important, right? It's very, very important. All right. So look, in conclusion, motherboards are the backbone of modern computing, and they are constantly evolving with new technologies and features. So understanding their architecture and innovations empowers better system design and enhances user experiences.